Hi folks, so today we'll talk about the sovereign data and in particular the verifiable data and trust. So, some way in August I made the article that trust is not verifiable, but I haven't made a video about it. So today we'll talk about the stuff. So when we talking about the classics of the self-sovereign identity, especially in 2020, it was obsessed with the verifiable credentials. So the verifiable credentials was everywhere, and it was only one way how we see the data. And the main selling point was that the data is unverifiable. But in some point, even the self-sovereign identity community started talking about the authentic data containers and authenticity of data instead of the verifiability of the data. So what happens and why the data is not really the verifiable as you think, or maybe they verify something different. Let's talk about this, because I think that it's quite big misconceptions and misunderstanding that is extremely important to understand. So what's actually happening when you want to verify the VC? First of all, if you want to verify the VC directly, you're probably doing something wrong. Because if you take a look to the trust triangle and the classical exchange protocols, you usually get the VP, so verifiable presentation from the user, not a verifiable credential. Why the verifiable presentation exists is quite simple. Because in a verifiable credential, you have a signature information about the issuer, but not about the holder itself. And that's the problem. In general, we could talk in a separate video the ownership of the VC and how to prove the ownership of the VC, because it's not so straightforward. But with the VP, what you usually do, that you get the request for submission, then you select the VCs, pack them to the verifiable presentation, sign it with your key, and then somehow it's the proof that your DID is the owner of the VCs that packed inside. But it's still the question how we get these VCs, how the VC connected to the identity, and all other thing about this we will not talk in this video. So it's the topic for the separate discussion, maybe for the panel discussion with some SSI folks keen to have it. But you get the VP, and then you have a lot of trust in a verifier to actually make sure that verify everything that we expect from him. So first of all, the verifier needs to get the context of the JSON LD context and make sure that JSON LD context match actually with the data. It's the first step. Then verifier should for sure verify the signature and the timestamp of the VP, and after that verify every VC and corresponding if VC is matched with the presentation submission and presentation definition, right? So it's already a lot of work, and at the end we need to validate every VC that in a VP and then give the final result. And quite often we don't have this detailed information that all these steps was made, all the steps are compliant. So quite often we just get true or false from the verifier. Then it's a full trust to the verifier that verifier actually follow all the steps. But still, even all these steps that we mentioned, they not verify the data. So we already know that it's practically no way to verify the ownership except of the signatures in a VP. It's one big challenge, and it's not clear to big amount of people. But the biggest thing that the data is not verifiable. So we not verify the data itself. We're not verifying the corresponding schema of the data or validity of the data. We just verify the authenticity and integrity of the data. Yeah, that you verify the signature, you make sure the data was not changed, and actually it's the same data as they was signed, but we not verify the content. And that's the problem. But then it's the question, who actually should verify the content? And then we have the bigger challenge that actually the first verifier of the data and practically the single verifier of the data itself, it's the issuer. It's the guy who issued the data, because issuer usually acquire the data from the party and then give the verifiable credential. And it's the point where the data and their validity should be verified, but it's not the verifier who verify the data. And maybe you have more complex flow that after the verification of the VC you do some data processing, some business logic on top of the data. Yeah, that's the separate question. But on practice we already see that first of all, we not verify the ownership because it's quite hard to verify. Only the VP give us something in this area. We do not verify the data. We verify mainly the data integrity. And then it's the valid point of actually the trust. How we trust to this process. And it's more fun thing. The trust is not the algorithmic or cryptographic operation. It's more the social and society thing. And even this mature technology, they have nothing in common in trust, because in practice, you should build the trust between the verifier and the issuer. And you need to make the issuer and verifier discoverable and trustful to each other. But even in the process of the verification of the VC, we have plenty of trust to the technology. And maybe this trust is not so visible to us. So that's another angle, that we have the huge budget of trust in the verification process. So what I mean that, first of all, you should trust the provider of the context, that this URL that give you the context is not hijacked, and you actually get the original context of the verifiable credential and VP. And maybe it makes sense to make it more secure and embed the context to the VP or VCs. It will make the payload huge, but it will make entire process more reliable. What will happen if the providers of the context will fail down? It's practically mean that your VCs are useless right now. So it's one thing. Another thing, that we trust in the DAD methods and the cryptographical suits, because when you have some particular DAD, for example the DION, we have full trust that DION nodes will be operatable, and we still are able to resolve the DAD. And we have a trust that the propagation actually happens. And if some of the DAD methods will fail to resolve, then it's yet another trust point, that we really trust in the DAD infrastructure. And the cryptography suits, what will happen, for example, if you have some DAD method and the signature that have the cryptography that are not known to the verifier, or maybe it's some kind of fraud, or maybe it's some kind of security and vulnerability leak in a cryptographical suit. So we have a trust not only to the DAD method, but we have a trust in a cryptographical suit. So you see, it's already the big thing. It's a couple of stuff, and it's even for the autonomous systems, it will be the valid points, because the more the dependencies and third-party systems you have, the more trust you need to invest. And things get extremely complicated and require the big amount of trust when you have the revocable credentials, because then you need to trust to the revocation list infrastructure. And the revocation list infrastructure actually have all these problems that the regular VC have, because it's yet another VC, but in the same time you could have the limitation of the revocation lists, the processing of the revocation lists, the standards. So we have a multiple standards of the credential status, credential revocation list, and all those things. And usually the revocation lists are semi-centralized things. I haven't seen any kind of revocation list in infrastructure that actually is not is centralized completely. So usually you have some web URL, and that's the problem. If you see some web URLs like HTTP blah blah blah, it's already the question, because you have the website that's hosting all the things, and actually it's an entry point to the central system. Then if we rely on the central systems, for example, for the revocation list and for the credential context, do we really have the decentralized solution? Probably not. We have a mixture between the decentralized solution and centralized points that used in a decentralized solution. So as you see that you do not have a trust, because the trust is the social, but you need to invest the trust. You need to invest the trust to the process of the verification, because it's quite complex technical process with the bunch of moving parts, and it's a lot of the points of the vulnerabilities, security attacks, and you really need to trust to the infrastructure. It doesn't mean that we don't need to trust to the verifiable credential, but it means that we need to be aware about the risks and the benefits and the downsides of the technical solution that we currently have, because it's simply unresponsible to others and to your customers just to blindly believe in a technology that may be not doing the work that we expect to be done for us. And I see a lot of movement right now in a authenticity, acyclic data containers, ACDCs, and some good work of Kerry guys in this space. But the general note about the Kerry community and Kerry based solutions, the Kerry, it's a hell complex thing, and the solutions around the Kerry infrastructure, it's usually hell complex too, and maybe it's too complex, and it's the main problem of adoption. But looks like ICDCs are more safe version of the verifiable credentials. But still, even with this infrastructure, you're not verifying the data, and the issuer is the guy who should verify and access the data. But we need to be aware that the verifiability of the data and data itself, it's not fixed in a time. So it doesn't mean that I have some data right now and provide this data to the issuer, and issuer validate this data and give me the immutable VC that this data will be valid in the future. So maybe we have time limited data, or we have something that's changing, and actually what was valid in a point of issuance could be invalid in a point of the verification. But it's a deeper technology and philosophical discussion. So be aware that trust is not verifiable, but the verification of the VC require plenty of trust to the infrastructure and solutions that people use. So that was my main message for today. Stay safe, stay verified, and see you next time.